Factoring monomials. Factoring out a monomial. So first let's define what factoring is. Factoring is, well, first off, it's the opposite operation of multiplying polynomials. So in a way, it's kind of like dividing, because the opposite of multiplying is like dividing, but it's going to be a little different than just dividing a polynomial. So one thing too, let's define before we start doing some of these. The greatest common factor, or GCF. So the greatest common factor, or the GCF, it's the highest coefficient and variables all terms have in common. All terms have in common. So let's do an example of just this first. So if you're asked to find the GCF of 6x to the fourth, 3x to the sixth, and 9x squared. So looking at these, just if we look at 6, 3, and 9 first, the greatest common factor of the numbers are what you can pull out of each of them. So what they have in common. So what they have in common is 3. You can't take more than 3 out of 6, or you can't take more than, well, 3 out of 3. But since 3 goes into each of those numbers nicely, that is part of the GCF, greatest common factor. Then if we look at the x's, the most that they have in common, they all have an x squared. But because of the 9x squared term, that's the most that we can factor out. So the greatest common factor of those three are 3x squared. Okay, so now what we're more so going to do, though, is factor, for our first example, we're going to factor 3x cubed plus 15x squared minus 30x. So when we're asked to factor that, first we look at what is the greatest common factor. So we look at, kind of one at a time. First we look at the coefficients, then we can look at the x's, kind of like we did with the last example. So if we look at the numbers, the coefficients, they all have a 3 in common. So we're going to factor out a 3, and they all have an x in common. So we're going to factor out an x. So the greatest common factor in this problem is 3x. Now the difference, though, is we're not just going to list that. What we do next is we start a parenthesis, and then whatever is left over when we factor out the 3x, we put into the parentheses. So if we took 3 out of 3, so the coefficient, what we're left with is, well, nothing or just 1. Take an x out of x cubed, and we'd be left with x squared. Okay, and then we go plus. If we take 3 out of 15, we're left with 5. And then we take x out of x squared, we're left with x. Bring down the minus. 3 out of 30, we're left with 10. X out of x, nothing, or it's like x to the 0, so we don't even show it. And I end my parenthesis. Okay, so that is my answer. Let's talk about this a little more. Let's say I want to do a check. Like I said before, factoring is the opposite of multiplying polynomials. So if I multiply this, I can check my answer. So if I distribute, 3x times x squared is 3x cubed, plus 3x times 5x is 15x squared, minus 3x times 10 is 30x. So then if I look at my original problem, I'm back to the same thing. So it checks out. One other thing I want to show you in detail is how this relates to dividing. So I'm gonna rewrite the original problem. 3x cubed plus 15x squared minus 30x. So if we go back, we still have to kind of look and say, okay, the greatest common factor is 3x. But if I divide, think of it like dividing, because it's the opposite of multiplying, remember. So if I divide everything by the greatest common factor that I figured out, notice I can see it a little more clearly. This is x squared in the first term. Next term, 15 divided by 3 is 5. X squared divided by x is x. 30 divided by 3 is 10. X divided by x, gone. The thing is, though, now when I put my answer, I still have to include the 3x in front, because it's not just saying divide the polynomial by 3x, it's saying factor it, which means I'm still showing what I'm pulling out in front. Okay, let's do a couple more. Let's factor 18x cubed minus 10x squared plus 22x. Okay, so kind of similar to the last one, but if I look at all the coefficients, I have 18, 10, and 22. So, well, they're all even, so I think probably just a 2, and they all have at the most an x. So now 2 out of 18, I'm left with 9. X out of x cubed, I'm left with x squared. Minus 2 out of 10, I'm left with 5. X out of x squared, I'm left with x. Plus 2 out of 22, I'm left with 11. X out of x, nothing. So again, even if we don't write it out, I'm going to go through and distribute and check. 2x times 9x squared is 18x cubed. 2x times 5x, 10x squared. 2x times 11, 22x. So I know I got it. Okay, how about this one? Factor negative 4x to the fourth plus 6x squared. So this one, if I look at the numbers, I can factor out a 2. They're both even, 4 and 6, and I can factor out an x squared. So if I factor out 2x squared, so I'd be left with negative 2. Negative 4 divided by 2 is negative 2. X squared out of x to the fourth, we're left with x squared. Plus 2 out of 6, I'm left with 3, and I took x squared out of x squared, so just left with 3. Now this one I set up a little different because I'm going to put a little or here, because sometimes I want that leading coefficient within the parentheses. I might want it to be positive. So another thing I could have done, and this looks a little better, if I take out a negative 2x squared, so if I took out a negative 2 out of negative 4, I'd be left with positive 2x squared. And then if I take negative 2 out of 6, well, that's going to have to go to minus 3, because negative 2 times negative 3 will be positive 6x squared. Okay, so notice sometimes we can factor out a negative. It's just going to be that all the signs on the inside are going to be the opposite signs. Okay, next, factor 9x squared plus 5. Okay, so this one, so if I'm looking at the numbers, the coefficients, 9 and 5, they don't have anything in common besides 1. And we don't really count 1 as something that's worth factoring out because it's just going to be the same thing in the parentheses. And they don't have an x in common either. So they actually have nothing in common. So this would be considered not factorable. Nothing I can do with that. So we would just say not factorable. Okay, one more. I want to get one in with x's and y's. So 35x y cubed minus 49 x to the fourth y squared. So looking at the numbers, the coefficients, 35 and 49, 7 in common. Looking at the x's, at the most, there's an x in common. Looking at the y's, at the most, y squared. So the first one, 35 divided by 7, I'm left with 5. X out of x, nothing. y cubed out of y squared out of y cubed. I'm left with the y. Minus 7 out of 49 is 7. X out of x to the fourth is x cubed. X squared out of x squared, nothing left there. Go back and check. 7xy squared times 5y. 35xy cubed. Minus 7 times 7, 49. X cubed, x to the fourth, y squared. So this checks out.